Since its discovery in the 1920s, penicillin has had an immeasurable impact on how we treat infectious diseases, and combined with its derivative compounds, the penicillins, is used to treat a wide variety of infections in both human and veterinary medicine. The penicillins, along with the cephalosporins and carbapenems, are all members of the beta-lactam superfamily of antimicrobials. These drugs are all cell wall synthesis inhibitors, which act by binding to and inhibiting the penicillin binding proteins in the cell wall. These proteins are transpeptidases and carboxypeptidases, which are involved in peptidoglycan cross-linking. And by inhibiting this final stage of peptidoglycan synthesis, the cell wall is weakened and the bacteria is ultimately killed. These penicillin binding proteins are not homogeneous among bacteria, and some organisms produce penicillin binding proteins with low affinities for certain types of beta lactam drugs. So, our enterococci, for instance, produce penicillin binding protein 5, which has a low affinity for the cephalosporins and results in intrinsic resistance. So, I think it's important to keep in mind that the composition of penicillin binding proteins is directly related to the susceptibility of the organism. These drugs are bactericidal, so they kill the organisms, they don't just inhibit their growth. And it's important to note that killing requires actively growing cells, so those in stationary phase are less affected than those cells which are rapidly dividing. Within the penicillin family, we have several subclasses. First, let's talk about the penicillinase stable penicillins. These include drugs like oxacillin, cloxacillin, flucloxacillin, and the mostly historical methicillin. These drugs have activity primarily against gram-positive cocci, and we think of them generally as being used for treating staphylococcal infections. In a veterinary context, drugs like cloxacillin might be used for treating mastitis, and in human medicine, flucloxacillin would be used for treating gram-positive septicemia. Our original recipe penicillin, so penicillin G, penicillin V, procaine penicillin, there's a number of different formulations, also have primarily gram-positive spectrum, although these drugs are also active against enterococci and streptococci. So when you think penicillin, think gram-positives. Our next subfamily are the aminopenicillins. These are our extended spectrum penicillins, ampicillin and amoxicillin, and these have the same coverage as our original penicillins, penicillin G, but with improved gram-negative coverage. So organisms like E. coli and other susceptible enterobacteriales can also be inhibited. The spectrum of activity of these drugs, the fact that amoxicillin is orally bioavailable, and their relative safety profile has made these commonly used tools in our antimicrobial armamentarium. Finally, we have the anti-pseudomonal penicillins, drugs like piperacillin. These have greatly enhanced activity against gram-negative bacteria, including most of our enterobacteriales, and even susceptible Pseudomonas aeruginosa. This anti-gram-negative activity comes at the expense of gram-positive activity, and so when you think of drugs like piperacillin, think gram-negatives. I hope this summary of the penicillins was helpful, and if you have any questions, leave them in the comment section below.